Hello, hi everyone. So welcome back to my channel and let's start with today's Leetcode challenge, that is smallest range covering elements from K list. Until now we have completed 5 challenges. In case you have missed any, you can watch it on my YouTube channel. I have created a playlist for the same. Okay, so let's just quickly start with today's question. So we have K list of sorted integers in a non-decreasing order. We have to find the smallest range that includes at least one number from each of the list. We define the range AB is smaller than range CD if B minus A is less than D minus C, or A minus C if B minus A equals to D minus C. Okay, and we have this example. Nums is these three are the list, sorted list, and the answer is 20 comma 24, because if you see in this 20 to 24 range, we have at least one element in both of them. So this is 24, yeah, it is in the range, and 20 is also in this range, and if you see 22, it's also in the range that is explained below. So let's just move to the intuition building part to understand this question. So let's just start this intuition building part. So we have this example and we have this answer. So how we can check it? Yes, as we have discussed, from 20 to 24 there are at least one element in each list, because 24 is there, 20 is there, and 22 is there. So we just need to check if there's at least one element. We can give that range stating that this difference is minimum for all of them. So if you see, let's just have a small dry run. If you check this range, 0, this is 0, this is 5, this is 4. If you pick 0 to 5, right, that can be one of your answer. But and because 0 is in the range, 4 is in the range, and 5 is in this range, but the difference if you see is 5, right? And if you try to pick 4 to 10, 4 is there, but yes, 9 is there and 5 is there. Yes, you can pick, but this is 6, so you cannot pick this, right? So you just have to minimize your difference, and you have to take some range that can help you build your answer. So since we have discussed few questions earlier, whenever I will give you one hint, that whenever you try to given this K thing in your question, you mostly try to use priority queue, right? That is heap structure. But we will not start directly. We will check how we can get this. So we will write these list separately. Okay, I will pick this list. Now we have our list. So for first, what we can do, we will pick one from each of them, right? So we have 0, we have 4, we have 5. Out of these, what can we take for our range? Okay, 0 and 5, because if we see 0 to 5 will give us 0, 4, 5, and all three are taken from each of these rows, each of these lists, and we can get our answer because our question is at least one element from each list, right? So 0 to 5 we can pick, and our difference is currently 5, right? Now since we are going forward, it can make our difference smaller or bigger. So what we can do, first we try to move from first list to its next element, because we need to have at least one element from each list, and if we take this range from both of them, from three of them, then only we can get our answer, right? So let's just take 10, and first we will remove 4. Okay, we will remove 4 and we will get 10. So we will write this like this. So at first step, our range was, our elements were 0, 4, 5. The range was 0 to 5. Difference was 5. Now at the second step, we are moving here, right? So 10, we have 0 and we have 5. Now if you see 0, 5 and 10, now our difference is 10, right? Since we know our difference is increasing, so which one should we move better? Because we have moved 4, that has given our bigger range. So which one we should have moved? we should have moved the smallest element, right? So what we have done, we did not have moved this 4, right? We have moved this 0. So now the second step should be what it should be. It should have been, now 4 was there, 5 was there, 9 was there. I'm just writing this sorted because to better have clarity what is a range. So the range is maximum this 9 and minimum is 4. So 9 minus 4, 5. Because in this range all the elements that are currently in every list are coming at least one element, because 9 is there in this list, 5 is there in this list, and 4 is there in this list. So our difference is currently 5, right? Now, which one should I move to make this difference smaller? The smallest one, because if I move 4 to its next, let's just say there was 5 again. So we have this 5, we have this 5, we have this 9. Now the range is smaller because the range become 4, right? Difference that we have to minimize. So every time we have to move smaller value. So now 4 is here. We have to move 4 to this. Now what is our range? We have 10, we have 9, 5. So 5, 9 and 10. Again it is 10 minus 5, that is 5. Our difference is still same. Okay. So we can pick any 0 to 5, 4 to 9, 5 to 10. We can pick any. And that is what we have to return. Now, which one should we move? 5, 1. So I will move 5 to here, 18. Now, at fourth step, what we have? 10, 9, 18. So 9, 10 and 18. This is giving us 18 minus 9, that is 9. We have increased. So there is no point, right? We will have to update our this difference. Whenever we get our difference smaller, we will update our, this is our maximum, so this is our minimum and this is our maximum. So initially what we will keep a minimum and maximum. Currently minimum is 0, maximum is 5. Whenever we get a difference that is smaller than current range, this difference, this is range, right? You can call it. So whenever a range comes which is smaller than the previous range that we have gotten at max, we will update the minimum and maximum. Now we will move, which will move 9. So 9 is here, we will move to 12. So now our this step is 10 we have, 12 we have, 18. So now this 10 and 18, 18 minus 10, that is again 8. Okay, that is 8. And our earlier range is 5, we don't need to update. Similarly, now 6 step is which one we should move? 10. So we have 10, we will move to 15. Now we have 12, 15 and 18. This is again 18 minus 12, 6, right? We have smaller, we have 5 earlier, we don't need to update. Now we are at 7th step. What we have to move? This 12. 12 will be moved to 20. Now our range is 15, 18 and 20. Okay, now it is 20, 15, that is 5. Okay, again it is still equal, so we can take any of them. So 0, 5 will also be right answer. Now we have 8th step. Which one is smaller? 15. We will move 15, right? Now our list is 18, 20, 24. Now 18 and 24 will give 24, 18, that is 6. Okay, and earlier was 5, so we don't need to update. Now our 9th step would be what we have to pick. 18 we have to move, we will move to here, right? So this is 20, 22 and 24, because we have 20 to 20 and the previous list is 24, right? Now if you see 24, 20, right? Now you have got your this range that is smaller than this previous range. Now you can update. So what will you update? 0 will be updated to 20 and 5 will be updated to 24, right? This is 20, this is 24. currently. So I will write it below. Minimum is 20, maximum is 24. Now what you should do, you will go till you reach any list end, because whenever you reach list of any list end, that means that earlier you have made your some range in that all of the elements, each of the element from list has come one time, right? Because if you reach here, that means somehow when you encounter this 26 and some element from this list and this, you have made your range in which at least one of them has come from each of the list. So what will you do at 10th? What will you move? 20. You will move 20. Now if you see 20, it is moved here. Now we have come out of this list. If you come out any of the lists I have said, you cannot take this range between 30 to 26, because you have to at least take one element from each list. So that means you cannot do 10th. You will just say that this was our this range values which are giving you best answer, right? So now the question arises, which data structures we have to use now? Which data structure we have to use now? Okay. Now if you see, we are using this sorted list. Why I've said? Because whenever you are using sorted, what you have to check for every time, the minimum, right? And since I've said many times earlier, this is dynamic. So whenever you are inserting any element in this list, it is like you are removing and inserting, and what you have to every time move, which element you have to move every time, smallest one. Because I've said, because this, whenever you move this, you try to decrease your range, so you need to move this smaller element. So this is dynamic. If you see that earlier it is the 045, then you remove 0 and it is 459, and again it is it should be sorted so that you can get 4, and you will remove 4, then again you insert some other element, again it is being sorted. So dynamic plus sorted, I've said this multiple times, this is priority queue based data structure. When you need dynamic sorting, you will use this priority queue. And if you see which one we are removing every time, minimum, so we need to have minimum. And this priority, whenever you use queue any, that means that you can remove the first element, right? So your priority queue should be of type, this should be of type min heap, right? So that you can directly access your minimum element at the top. So our data structure is min heap, right? And we can directly use it, and what we have to store every time, that is also thing, main thing. So you are storing each element from this list first, right? So this is 045, but how you can know that this 0 has came from which list, right? It should be from any of them. So you have to somehow keep this indexing of list in your this priority queue, right? And if this list is this is okay, and if this list has reached till end, how you know that this list is basically reached till end? So you need to keep the indexing of element, right? Because you need to move from 0 to 9, you have to keep what is this index 0, you have to move to next index, right? 1. So indexing of element is required, and again indexing of row, which row you are picking, which list you are picking, row or list, you can say it, like, you can say it anything. So you need to keep indexing of element, indexing of row, and the value that you are storing. So three things required to store, that are value, current, list, index. List index is which list you are picking. So k, which k you are picking, as mentioned that they are k list. And current index of this list, right? Because you have to move from 0 to 9 or 5 to 18, you have to somehow keep this index 0, 1, 2, right? So these three things are required. So now you have your priority queue with all these values, and this will be of many type, so you can get your answer, right? So now we can just do the small try run for the other example. That will be a smaller one only, right? So we have this 1 2 3, 1 2 3, and 1 2 3. You will be at starting for each of them, right? So you will pick 1 1 1. So this is your, let's just say this is your priority queue. 1 will be stored. So this is 0 list, this is first list, this is second list, and indexing is also 0 0 0. So 1 will be stored with this index 0 and this 0 row, right? Similarly, 1 will be stored with 0 index, this is index. So first is value, second is index of value, third is index of row, right? Value, then index of value is 0 and index of row is 1. Similarly, 1, 0 and 2. Since all these values are equal, any of them can be at this top mini. Now you will remove this and check, because you have to remove at least one of them, and your range is currently 0. 1 minus 1 is 0. So your answer is currently 0. Now you will move this 1, okay? Because you don't know if you get some other range. So you will move this, sorry, this not. So we have kept second row. So you will move this one to here. Now you have 2. So what you will do? You will remove this 102. Now you will insert 2. What is the index? Index is 1 and row index is 2, right? Now if you sort it, what you will get? 1, and any of them can be at that first. So 1 with their index is 0 and the row is 1, 1 with 0 index and 0th row, 2 with first index and second row, right? Now what is your range? If you check in this list, 1 is your minimum and the maximum what you can get, again 1, sorry 2, right? 1 1 2. So now your range is 1, which is not your good answer. Again, you, which one you will move? Again this one. So this is worst, so you will move here. Now your 2 will be added. What is this index? 1, and the row index is again 1. Now again this will be sorted, right? So this one will come above. So 1 0 and 0. Now what is your range? 1 2 2, and again this is 1. You will not get your answer. Similarly, so whenever we take out this top one, we will update our minimum, because this is our minimum, right? So we will assign this minimum value to our minimum, and maximum was our, the maximum that we have until now, and the next value to it, right? Because that is our maximum. Now you will 1 to 2 have done. Now what you will do? You will remove this 1 0 0 and move here again 2 with 0. This is, sorry, 1 and 0. So you have 2 2 2. What you will get? Your gain 0. So this is currently equal. You don't have to update your earlier range, that is 1 1, because first you have got this value at 1 1, you will not update. Whenever you get less than, you will update. So similarly you will move which one of them to here, right? Now you got 3, 3 will be inserted with 2 index and 0th row. Now it will be sorted and this one will be at the top. So you will add this 2 2 3, your range is 1, you will not update. So similarly you will get until any of them reaches the end. So when you reach the end, right, you will just quit this, because you cannot take any of the value from this list to make your answer, right? So main thing comes now, time complexity and space complexity. If you see what we have taken, this min heap, so time complexity and space complexity, at max how many elements we are storing? Maximum 3 elements, which are each of them, right? So space complexity is directly big of k size, because k is the size of the list, number of the list we are getting. Now time complexity, because you are using a min heap, so this heap operation takes log time, so log of k, because k elements you are storing. Now since you are iterating over all of the elements in these all lists, so n elements you have, so if you go for each element using this priority queue, so it will be log k star n, so n log k, right? So this is our time complexity and space complexity, and we have built our intuition. So now just move to the coding part to better understand it. So let's just start with the coding part. Okay, do it like this. Yeah, it is visible now. Let's just store the size of the this array that we have, nums array. It will be k. Right now what we have to do, we have to create a priority queue of min heap type. So since now what we have to do, as we have discussed, what we have to store, 3 things to store. What are these things? These 3 things. First is value, current value, and the second is that index of the value. So index of value, and the third things that we have to store is index of row. Basically row means, or we can say, as we have discussed, this list also, because this is first list, this is second list, and this is third list, right? So this will be 1 2 3. Now we will be storing that in a vector, right? And if it is vector, then for creating a main heap will be vector of vector in type and greater vector int priority queue. Okay, now we have the priority queue. First we will create a maximum value that initially will be aligned, that initially will be assigned minimum, and minimum value that will be assigned int maximum, right? Now we will go for all the list 0 to k plus plus. Now we have our ith list, so we have to insert that value in our priority queue. So it will be nums of, this will be ith list, and initial value will be 0. Similarly the index of value, it will be initially 0, and the row index will be I, right? Now we have to make our maximum, so it will be maximum of current maximum and this value, so it will be right. And now for minimum, minimum of this minimum and nums of again I and 0. So we have our maximum minimum initially for the first thing 0 4 and this 5. Now we will go while this priority queue size is equals to k, right? Now we will get our first that tuple. So tuple, it will be this priority queue dot top, and then we have to remove that value also because we have to insert the new value. So it will be pop. Now current value will be this tuple 0, and this current val idx will be tuple 1, and current row will be tuple 2, right? Now we know that when every time that we are getting this value, we have to, that will be our minimum for the current thing that we are doing, as we have done in that example. For 0 4 5, 0 will be at starting, so that will always get our minimum for every range. So we will update our minimum to this current val. Okay, now what we have to check, if our maximum, okay, maximum we already have gotten while we are getting this, so 5 we already have, and when we get this, so it will be maximum minus minimum. If it is smaller, then what we have to do, we have to return it in the form of vector. So what we'll do, we will create another vector of answer type that will initially store the final answer that we have to provide. So for first, this will be our final answer, so it will be minimum and maximum, right? So these will be compared with whom? These minimum and the maximum that currently we have will be compared with whom? That answer of 1 and 0, right? Because we are storing in that answer vector. If it is 2, then we have to update our answer. Answer of 0 will be our minimum, and answer of 1 will be our maximum, right? If it comes in this, it will be updated. If not, then we have to do for next set of work. So 0 will move to 9, right? Now when 9 comes, the list was 0 was at first, then 4, then 5. Now 9 comes, 9 has to come after that 5. So it will be automatically sorted, but 9 will be our maximum. And when we compute for 4, 5 and 9, we have to get this 9 somewhere to compute that difference. But when this is a priority queue, and we did not get directly that value, so before that only we have to update our maximum, and maximum will be maximum of this current maximum and the number that we will get after 0. So it will be nums of current row will get our this list, then current value index, this will be our this will get our 0 value, but if we update it, this will get our 9, and we already got our maximum which we need for next set of computation, right? And now we will push this priority dot push, priority queue dot push, but we have to push this value 9, right? And index will be this current value index plus 1, right? And row will be similar now, so row will be current row, right? Now since we know whenever any of the list becomes like comes to an end, what we have to, we will not get this value and we will get error while computing that. So beforehand we have to check if this current value index plus 1, if it is going out of bound. So if it is nums of row, current row, so that is that list, and this list dot size, if it is going that bound, then we have to break from this loop, right? So I think we have got our answer. Now we just have to simply return our answer vector. So let's just try to run it. Yes, it is working fine for these. Let's just try to submit it. Yes, so we have submitted this successfully. Thanks everyone for watching. In case you do like this video, please do hit that subscribe button and turn on the notifications for more solutions, and we will be together completing all the challenges. In case you have any approach, please do share that in the comment section. I will review it, and if you have any questions, you can DM me on my Instagram, and I will add the solution also on the GitHub link that I provide in the description. Thanks everyone.